For number 14, this is where we get onto those graphing problems, okay? These graphing problems. Here we got the graph itself, and then we've also got an equation in factored form, and we want it in standard form, okay? This is where we do our distribution multiplication, or what I found a lot of you still doing is using the box method, the multiplication for this, okay? It's the opposite of factoring. We put the pieces on the outside, and we multiply them in. Our diagonal has our like terms. And this is the part where people get a little bit off kilter. Look what was sitting out there to begin the problem. That means it's still sitting out there. And when we use it and combine like terms with it, it actually changes our equation just a little bit. If you're given the graph, you can check this to make sure we did this right, making sure your graph or your equation you just created matches the one graph. X squared minus 4x minus 4. I would advise making sure not only that yours matches, but that you go ahead and graph it anyways, because then you can be very precise with your future answers. So write in standard form, we already did that up here, okay? Find the max or min. Well, it looks to me like it's at 2, -8, and that's great because we can eyeball that one. We can just look at the graph and figure it out. But if you wanted to calculate it, second calculate, minimum, and then we got to sandwich it in. I'm to the left of it, press enter. I'm to the right of it, press enter, enter. And ours says 2.0000012 -8. That's basically just 2 -8, guys. With the y-intercept, it's similar. It looks to me like it's at 0, -4. I'm going to change colors here. I'm going to do the intercept in green, 0, -4. I don't want people getting confused. This is the y-intercept. Zeros are x-intercepts. Next question is D. It's interval of increase and decrease. So I look and I say, okay, what does my graph start off doing on the furthest left portion? Well, the furthest left portion is here, and it's decreasing. And it's decreasing and decreasing, and it stops decreasing right here at the number 2. That's my x value. So from -infinity all the way to the left to 2, it's been decreasing. At 2, it changes its direction and starts increasing. So as we move to the right, we are increasing, meaning from 2 to positive infinity. Guys, please remember, between these two answers of interval increase, decrease, you're always going to have -infinity, comma, a number, and then that number, comma, infinity, okay? It's always going to be those two answers. Where you have to decide is which place one goes into, okay? -infinity and then to the number, and then from the number to positive infinity. They don't always go with this top one being decreasing and this bottom one being increasing. It depends on the graph. Depends on if it has a min or a max. But just know that your answers should always look like that. Speaking of what should answers look like, oh, if I had an eraser. There we go. For end behavior, you're always going to write as x goes to the left and as x goes to the right. That's -infinity to positive infinity. Then you're going to have to fill in what y does, because that's the question it's asking. He's saying, hey, as we go left and right, are we going up, down, flat? What are we doing? And we can see on this parabola, both arrows are firmly pointing up to positive infinity. So that's my end behavior, the behavior of the ends of my graph. Positive infinity and positive infinity. Number 15 is a slightly more complicated graph. Because look, guys, it doesn't look like it perfectly comes to a maximum. It might, but it's going to be a little bit shaky. So we're going to want to graph this one ourselves. Okay? But the first part says determine A, B, and C. A lot of people got confused. They thought that meant here, here, and here. It probably should have been worded a little bit better by me. What this is A, B, and C means our standard form of ax squared plus bx plus c. Okay? So what it's wondering is what's A, what's B, and what's C? A equals -1, because that's the number in front here. B equals 5, and C equals 14. Okay? Then we get into some of the real problems. Okay? Well, that wasn't a real problem, but now we're into some stuff where you've really got to know some of your calculator tricks. We want to find the zeros. If I'm looking at them, I'm thinking it's -2, 0 and 7, 0, but I don't want to leave that up to chance. So I'm going to hop in my calculator and I'm going to let it do some of the work. Okay? I'm going to zoom 6 this thing, and I don't think it's all going to fit on the graph because I was just looking at how big theirs got. So I'm going to zoom out one time, see if it looks a little bit better then. And there we go. I can't see exactly where these zeros are now, but I can see them enough to calculate them. Second, calculate, 0. We go, I'm looking at this very first one. This is a 0. It's where it crosses the x-axis. If I want to calculate it, I go to the left of it, press enter. I go to the right of it, press enter. What I've essentially just done is sandwiched it in. And it was -2, 0. But it wants both of them. So I calculate the second one by sandwiching it in. Go over here near it, sandwich it in on the left, sandwich it in on the right, and it was 7, 0. So they were what I thought they were, but I was just being cautious. Next, C says find the vertex of the parabola. Vertex in this case means min or max. So I need what is I can see to be a maximum. Second, calculate. Number 4 is maximum. Left bound, meaning sandwich it on the left side. There's on the left side, sandwiched in. Now let's hop way over to the right side of that same maximum. There we go. Sandwich, sandwich. My maximum is 2.5. Don't give me all these crazy decimals. That's just your calculator pinging back and forth and kind of rounding a little bit. 2.5, 20.25. Domain, okay? Domain. I'm going to clear out these writings just so I will. No, that'll be fine. I'll just do it here. Domain means all possible x values, okay? If it's not specifying to just talk about the problem, if it's saying the whole graph, our domain is always -infinity to +infinity. Some people write all real numbers, okay? Another way to write it would be -infinity. I don't want to write that one. That one's rare. The less than or equal to x, less than or equal to, yeah. Next, though, we're on to our range, okay? Range or rangy, if you've ever had Coach Setzer, that's his call out. He remembers range is always rangy, meaning it has to do with y values. And that's a little bit more specific on this problem, okay? Because our y's don't go up and down forever and ever and ever. They have a unique stopping point up here at the maximum. It's like an asymptote. We're never going to go higher than that maximum. So, what are our possible y values? Well, y can be anything less than or equal to that maximum's y value of 20.25. I do want you to know the alternative way to write this answer. You could write it as -infinity up to 20.25. A very accepted alternative way to write that method. You need to know both.